Hello, everyone. My name is Pisha Rodriguez, and today I'll be talking about the effects of forest fragmentation on ant-falling birds in the Brazilian Amazon. So before we get into the birds, it's important to understand the ants that follow them. In the neotropics, there's a group of ants called army ants, and one of the most important species is Eceton bertellii. These ants are group predators that swarm the forest floor in search of arthropod prey, and in doing so, they flush up huge masses of insects, and this provides a rich resource for ant-falling birds. However, the ants are nomadic, and rather than having stationary nests or colonies, they form temporary mobile nests in the form of giant balls of ants called bivouacs. They follow along a continuum of specialization from occasional ant-following birds that opportunistically forage at swarms, all the way to obligate species that depend almost entirely on swarms for food and that have developed specialized behaviors for finding and tracking army ants. Ant-falling birds fall under a larger umbrella of terrestrial and understory insectivores, which have consistently been identified as among the most sensitive tropical birds to anthropogenic disturbance. Given the current rates of tropical forest deforestation, discovering the mechanism behind these declines will be of huge consequence to tropical avian conservation. So what is it about these ant-falling birds that makes them so vulnerable to forest disturbance? Well, as you can imagine, finding a bunch of ants in the middle of the rainforest is a difficult task. So the obligate ant-following birds have evolved special behaviors for finding and tracking ants. These behaviors include bivouac checking, where the birds will go to known locations of army ant bivouacs and check to see whether the ants will be swarming on any given day, as well as social information use, whereby birds essentially eavesdrop on the vocalizations of obligate species to find ants. And because obligate species are more equipped to track the ants, other birds depend on obligate ant followers to find the swarms and to find food. So we know that obligate ant following birds decline in fragmented forest. I wanted to know what happens to ant following bird flocks as a result. I hypothesized that birds would flock less frequently in forest fragments compared to continuous forest, and that flocks and fragments would have fewer individuals as well as fewer species than flocks in continuous forest. To answer this question, I used 40 years of bird capture data from the Biological Dynamics of Forest Fragments project in central Amazonia. There are 3 obligate ant followers that occur there: the rufous-throated ant bird, the white-chinned wood creeper, and the white-plumed ant bird. So I virtually recreated ant-following bird flocks using a combination of space, time, and species constraints. Basically, if a bird was captured within a certain time and distance of 2 or more obligate ant-following birds, those birds constituted a flock. And after looking through the resulting flock data, I established a threshold to filter out potentially false swarm detections. What I found was that flocks did form less frequently in fragments compared to continuous forests. Here we have flock frequency plotted against years following fragment isolation, which is represented by the black dotted line. The green dots represent fragments and the orange dots are continuous forests. So what's important here is that you can see outlined in red all of the years where no flocks were detected whatsoever in fragments. I also found that fewer individuals joined flocks. So here you can see individuals per swarm with years after isolation on the x-axis. The flocks in the fragments, so the green dots, have relatively few individuals compared to the continuous forest flocks. What's interesting here is we can see that in the 4 years prior to isolation in the 10-hectare fragments, there are far more flocks and individuals than in the remaining 30 years combined following isolation, and that the flocks in the fragments never quite reach the same size even decades later. Lastly, looking at species richness per swarm, we saw a similar pattern. There are few flocks with high species richness in fragments, and the flocks in the continuous forest often had 5 or more species and even upwards of 10 or 15 species. And as with the number of individuals, species richness prior to isolation drops off dramatically following isolation in the 10-hectare fragments and never quite reaches the same number of species per swarm. Moving forward with this project, I would like to create flock association networks to examine relationships between birds in finer detail. I'd like to thank my advisor, Phil Stouffer, and everyone at the BDFFP who made this possible, as well as LSU and the School of Renewable Natural Resources.